And it says we are now recording with apologies to last time. What happened was, if you recall, I had to take a quick break in the middle to go take care of a dog. And at some point during that, I managed to turn off the recording. So I did not actually have a recording of the lecture. And since the second half of the lecture was spent working on Project 2 stuff, we lost that. So I did, that's why there's no lecture from Wednesday the 21st on YouTube. I did record a separate lecture, a separate iteration of me going through and developing that same code. So there is a video on YouTube from last Wednesday night of me walking through that code and showing how to read in a CSV file and creating the 2D lists and then inserting the column with the sum of the project scores on the 2D list. That is up there, although for some reason that also had no volume, but at least the coding is there. You should be able to follow. So hopefully that was helpful to you. As I said, I am checking to make sure that I am indeed recording this lecture today, so we will have that. We want to get started with what's going to happen in Project 3 for our section. I mentioned last time that this is the part of the course where we veer off from what the majors are doing, and we try to provide material that's going to be more generally useful to you in your academic career, in addition to teaching all the fundamentals of computer science and letting you use the skills, showing you how to use the skills you've learned in your, use Python to actually solve problems. It turns out, we're going to talk about Lab 12 in a minute, that you're going to have tomorrow, is actually sort of related to what we're going to be doing. So I'm going to talk about that briefly on the next slide and how it's related to what we're going to be lecturing on today. A reminder that Project 2 is due tonight. I've already granted an extension to a couple of you. If you have not done it yet, if you need more time, if you have a good reason, let me know. I understand in the terms of the pandemic, people have got family issues, people have got other things going on. If I have to, I can give you a couple of more days. Make sure you submit what you got, let me know, and we'll work with it. Project 3 is supposed to come out today at this instant. Trust me, you do not want to see it. It is not ready. It will be released as soon as I finish it. Nominally, the due date is the 12th, 2 weeks plus 2 days from now. The 12th of May, 2 weeks and 2 days from now. I can extend the due date if necessary. A reminder that the final exam in this class is Monday, the 17th of May. The 17th is that Monday of exam week. It's scheduled to be 3:30 to 5:30, and it'll be like the first two tests. It'll be on Blackboard. If you have an issue with taking the exam at that time and date, let me know. I've already had one student who has a very valid reason for missing that time and date, so I'm making arrangements for that student. The issue really, I can configure Blackboard to make it available at whatever time you and I agree on. The issue is my availability if you have questions. I would hate to have a situation where you're taking your final and you don't understand one of your questions, and I'm in a key meeting with somebody in California and breaking out of that meeting to answer your questions and problems. So if Monday the 17th is going to be a problem and you have a valid reason for not being able to do it then, let me know. We will try to work out an agreeable time where I can at least monitor to find out if you are asking questions. Keep that in mind. A note on Lab 12. You will have it tomorrow. It's sort of related to some of the things we're going to talk about today. It's really focused on what's called virtual environments. Now, I have a little bit talked about, last week I rushed through the notion of a virtual environment. What a virtual environment does in anything, and in Python in particular, is it lets you set up a software-based environment for your programs to run that makes it look like you're running on a hardware-based machine. It looks like you have a machine to yourself with all the tools you need to run your program. And this is a really cool feature to have. I mean, in the simplest case, this is what cloud computing is all about. This is what server computing is all about. This is what shared networking is all about. This sounds negative, maybe even pejorative. I'm going to say it anyway. In a sense, you and I waste a lot of money when we buy a laptop and use it for our personal work projects, school projects, what have you. Because the reality is this Macintosh sitting in front of me that I'm looking at right now, and the Windows box that is right behind it, don't get used very much. I mean, I do all my stuff on them, but I probably use them over time 5 to 10% of their capacity at most. Okay, so it's more efficient if you just buy one computer, let 20 people share it, each using it 5% of the time. But you can't let them, you have to let them share it. And so what you do is you build a virtual environment on them. And a virtual environment includes something that looks like it's the processor, the CPU chip. It looks like it's the networking interface. It looks like it's the screen. It looks like it owns the whole thing. So that's what a virtual environment is. It's all software based, and it's going to be emulating the computer. So your Python program thinks it's got the whole computer to itself. It thinks it's got the Python interpreter. It thinks it's got the file system. It thinks it's got the screen. It thinks it's got the keyboard. It's got the whole thing, while in the background other things are running. Now, in addition to sharing things, the advantage to this is you can let things run that don't interfere with each other. And for our sake, here's the case. We've talked this semester about the different versions of Python. During the semester you've been in this class, there have been 2 new updates, at least, to the Python interpreter. I don't make you upgrade. I mean, it's not relevant. The changes they're making are not relevant to us, but sometimes they are. So what if you've got a Python program you wrote last year that runs on one version of the interpreter, and then next year you've got to write another program that runs on a different version? What you can do is you can set your system up with a virtual environment. We're going to demonstrate this, at least on my Mac with PyCharm, later in the lecture. You can set this up so that it your program will still operate with the version of the interpreter, with the version of the support packages, with all the software that you think you need, and you don't have to change it. And other programs will run simultaneously on the same computer, but with different versions of the tools, so you don't have to upgrade. It's a really nice way. Virtual environments are a really nice way of letting you manage and control everything you're doing, which is why they're used. So in Lab 12 tomorrow and later this week, you're going to be using virtual environments on GL. You're going to do your lab on GL, and you're going to use virtual environments, and it's going to demonstrate it. What we're going to talk about is if you want to do Project 3 on your laptop, on your computer with PyCharm, how to use virtual environments to make it run. And we're going to demonstrate that today. So Lab 12 actually does relate a little bit to what we're going to be doing in this class. And I just wanted to give you a heads up that you have that tomorrow, and that's why. This is just a notion about in Python and virtual environment and more. So not to steal Kevin and Mariah's thunder. What I wanted to talk about now is importing and using code in Python. And last Monday, I think it was, last Monday the 19th, in that screaming rush through everything we're going to cover the last 4 weeks of class, I talked about this a little bit, and now I want to demonstrate. And the first thing I want to do is demonstrate your own code. So what I have done is I went in and I created in PyCharm a program called placeholder.py. I don't have very much imagination. Placeholder is not an imaginative name. It's exactly that. What is placeholder.py? It is a place where I put functions that can be used anywhere. So in the file, I have a function called square. Square is exactly like its name implies. It takes a number and returns you that number squared. I defined a function called cube. Cube takes a number and returns that number cubed. Boring. I decided I could be a little more adventurous, and I defined a function called mean. Mean takes a list of numbers, and it returns the arithmetic mean, the arithmetic average of the numbers in the list. Okay, they're not very exciting functions, but they're functions in Python that work. Now, I wrote a main program and that only consists of one line, a print statement. And the print statement says, the main program can't be imported. Let's double check this, test as you go, and make sure that placeholder as a program actually runs. It runs, the functions are never called, but it runs, and it says the main program can't be imported. Life is good, placeholder.py exists. If I cared enough, I could write some code in the main program that exercised the functions above, but I don't want to do that because that's not the focus of the lecture. We'll worry about them later. The point is that placeholder exists and it has these functions in them, square, cube, and mean. Let's go to today's main Python program. Okay, and this is called April 26th coding.py. And yeah, I will try to remember to get this up on GitHub. Somebody remind me later on if I don't put this up for those who want it. Here's the deal. I'm going to have my regular main program in April 26th, just like we always do. Now, I want to calculate or prompt the user for a number and calculate the square of that number. Pardon me. I've got this big thing on my screen where PyCharm is trying to get me to update. Right now would be a terrible time to update, so let's not do that. Okay, well, this is fairly easy, right? Number equals int, we'll just use ints, not floats. Input, enter a number, and we'll tell you it's square. S equals. Now, obviously, I could calculate the number squared right here. I'll put that there for now. Print the square of num is S. And this should, testing as we go, hang on, this should work. There we go, April 26th coding. Enter a number and we'll tell you it's square, 4. Sorry, in the wrong box. Square of 4 is 60. Okay, a nice simple program. There we go. And another demonstration of you got to keep in mind what you do. But, you know, here's the thing. Yeah, this is a trivial function. This is simple to do. This is, you know, what have you. But the point is, I've already written this code. Okay? I already wrote this code. I wrote it over here in placeholder. Right? I already wrote this code. Why do I want to write it again in a different program? First of all, it seems ridiculous to have to do that. And second of all, I may get it wrong. So Python lets me take advantage of the fact that I've already written the code and use it again. The way I do that is with the import statement. Import placeholder. Now, Helps if I get the right comment sign. This works for any program ending in .py that's in the same directory or path. So in other words, remember the same issue we had with opening a file for reading or writing in Python? You had to know the right directory. It's the same thing. If this file is in the same directory, and here's the key, it has to end in .py, meaning it's a Python program, I can bring in this file and use it. So I don't have to say import placeholder.py. I just say import placeholder. Python appends the .py. Now what it does is it makes those functions available. Here, finally, is why this is important. The if name equals main is important. We can use any function from the placeholder.py file. We cannot use code in placeholders main program. Okay, let's think about this for a minute. What this means is that anything in placeholder that's defined as a function, square, cube, and mean, we can now use in this second program in April 26th, just as if we were in this same program. Just as if we were over here, we can use those same functions. If it's put in the main program down here, we can't use it. So here is why this statement that we've been using all semester, or 2/3 of the semester without explaining, has this syntax. This is why it's if name equals main. This code, in this case, just the print statement, but any code after this, this will only run if this file, whatever .py, is running as the main program. This code is only executable if this is the main program. All this other code can be imported and used whenever. Anything above here can be imported and used by some other Python program without a problem. This stuff will only execute if this file is running as the main program. That is the reason. That is the reason for this syntax for if name equals main. Says everything after this is only going to run if this is the main program. Previously, and some of you may have seen it, and a couple of you have tried to use it. I try to flag you when you do. It used to be def main, define this is the main program. The syntax changed to make it clear that this code is only running when this is the main program. It's not important. All this other code can be run either when this program's running or when it's important. Okay, fine. Now, syntax side note, let's get back to how we do this. Let's comment this out. I've already written the square function from the other program, and I need to know how to call it. Well, there is a term called an application programming interface, or API. The API is really just what is the name of the function and what are the parameters. If I know the name of the function and I know the name of the parameters, I can call the function. That's an application programming interface, API. For our purposes, name of the function and its parameters. I have to know what I need to pass. In this case, the name of the function is square, and it has one parameter, which is the interface, which is the integer number that we're getting. So let's, instead of saying s equals num times num, let's say s equals square of num. Now, this should fail for a reason I'll explain after it, I hope, does. Let's run this program again. Enter a number and we'll tell you it's square. 4. The name square is not defined. Here's why. Python does not know that I want to use the function from placeholder. I imported placeholder so I actually can use the function. And I need to tell Python it actually has to use that function. So the syntax is doing it this way. And I've got the slides. When we get finished with this, we'll go back to the slides and I'll work through all the different variations. Placeholder.square. This statement tells Python, use the function square that you got from placeholder, and you imported placeholder up here. And if I've spelled everything right, now when I run this program, I should be able to give it a number and we'll tell you it's square. 4, the square of 4 is 16. So now this actually works. So this is an example of writing code in one file, leaving it here in placeholder, and now I can use it whenever I want. I never have to write the function square again. I just import it. I've already written it and it's already done. Now I could do this, with a more meaningful function. L equals input, enter a list of numbers separated by tabs. L split equals L dot split on a tab. Pardon me, I cannot type today. Average equals placeholder dot mean L split. Print the average of your numbers is F. Now, let's see if this works. I'm going to take this code that I already did, and I don't want to run it again. So I'm just going to comment this out. Okay, I'm just going to comment the previous stuff out so that I don't have to go through calculating a square again. Okay, now why doesn't it like the indent? It doesn't like the indent for some reason. I probably got some bizarre comment somewhere. Oh, I'm reusing all the double quotes. That's going to cause an issue. Let's see if I can use single quotes and get them all out of there. Okay. All right. We're just going to calculate the square again, so I don't have to figure out why the comment doesn't work. Let's run this, see if we can do this without getting an indentation error. Okay. The answer to that is reminding, I was testing you. You should have remembered that variable names cannot contain dashes. That was the problem with that one. 4, Okay, now enter a list of numbers separated by tabs. 1, tab, 2, tab, 3, tab, 4, tab, 5. And it helps if you fixed your other. Python, by the way, was interpreting L dash split as L minus split, and it didn't like that. Let's run this again. 4. 1 tab, 2 tab, 3 tab, 4 tab, 5. Silly me. I forgot to convert them to integers. We're going to try one more time and then I'll move on. Success! I finally figured it out. Okay, quit making silly errors, on things that were taught the first 2 weeks of class. Okay, the bottom line is this. I imported the function that I had written over here, this function specifically, and I no longer had to write this function ever again. I simply imported it. So that is how you import code that you've written. And it's a very nice feature to have as you get more and more into your coding, because you might, depending on your problem, you might write a really interesting routine that solves matrices, finds eigenvectors of matrices, calculates the determinant of a 3x3 matrix. You might, write something like this that you want to use again and again, and you simply import it in Python using the import statement and remembering the syntax of how to do this. But it's really more than that. You can import a lot of code that other people wrote, and that's one of the reasons Python is such an important language. I mentioned this, I blasted through this last Monday. There's an entire math library that you can import, and here is what's in it. Now, these are the APIs of the math library. So, for example, there is a ceiling routine, ceil. It returns the smallest integer greater than or equal to a particular floating point number. Okay. So when you import math, you import ceiling, combinatorics. Comb tells you how many different ways there are to combine or to choose k items from n without repetition and without order. It's a combinatorics answer. Copy sign, it returns a float with the absolute value, but with the sign. Floating point absolute value. X factorial, the floor, the opposite of the ceiling. Modulus, floating point regular expressions, summations, greatest common denominator, is close if they're close enough to each other, infinite, is infinite, and so on. You can go through these. These are the APIs for the functions that are in math. So anytime you import math in Python, you now have access to all of these, and you can see that you didn't really need to write functions for some of the things that we've talked about they're already there. Okay. Exponentiation, logarithms, trigonometric functions, hyperbolic special functions, etc. You don't have to write them, they're already there. I mentioned NumPy. NumPy contains all the Python functions that you want to do numerical analysis of big data. Okay, and here's all of the details, and you can go through it. You might get into that with Project 3. We'll talk about it later. Pandas is panel datas. Pillow. Matplotlib is a way to do a lot of plots, mathematical plots of functions. ggplots as well. Okay. There is a really cool place that has a lot of Python libraries and packages that you can import and you can look through them. Okay. Pillow is an image library, PIL, image library. It's a lot of graphics and things like that. Matplotlib I talked about is you can draw bar charts, you can draw line plots, you can draw scatter plots, you can do all kinds of things. NumPy is up there. You can do some advanced numerical methods. Computer vision. If you want to get into image processing in computer vision, there's a library that's already written that you just pull in and so on. So we're not going to waste more time going through that, but you really should look at that and see all the things that you can do. Now, when you're importing code, any of these libraries that exist out there, you import it, and you import it exactly the same way you imported the code that you wrote. Okay, I showed you in PyCharm already how to import a program that you've already written. Well, you know the API because you wrote the original code. So you just tell it the function and the parameters. You can import anything, and if you need to know how to use it, you go to this description that tells you the API. Import math, this import Hailstone. I should have commented that out. There was a homework assignment earlier, but I think we skipped that. That tells you how to do it. Now, formats. What I used is what is called the basic format. In the basic format, you import. In our case, it was the placeholder program, or if you're importing the math program, you just say import math. And then you have to give the module name in each function call, x equals math.sign. I want to use the sign routine from the math function. So I'll come over here and I will import math. I will import the Python math library. Okay. Now, I want to calculate the sign of a number. Let's go back, and if you remember, signs can be expressed in radians. You can take the sign of an angle in radians or in degrees. So let's go back to the mathematical function and find sine that's the arc sine. I don't want the arc sine. Here we go. And look, the API tells me that this function returns the sine of an angle expressed in radians, not degrees. So I don't want to say what's the sine of 90 degrees. It will take that as the sine of 90 radians, and I have no clue what 90 radians is. It's about 14 times around a circle, right? So we don't want to do that. But knowing the API, knowing the application programming interface, now I'm going to go to a Python console so I don't have to keep rerunning my code. So what I'm going to do is I'm going to say import math. Now, print the sign, let's say, yeah, print the sign of 3.14 being pi over 2. First off, I'm going to get an error. because sine is not defined. Once I did import math, the basic import back from the slide, I have to tell Python I want sine from the math routine. So I have to say print math.sine 3.14 over 2. So the sine of pi over 2 radians, we know mathematically is 1, right? If you take any math or physics or whatever class, you know that the sine of pi over 2 is 1. Well, that's a pretty close approximation because 3.14 is not equal to pi, so good enough. Okay. Just out of curiosity. We'll have to see if we can figure out exactly later on what pi is. I don't want to distract myself here without seeing a squirrel. We'll have to figure out what pi is later on. That is what that slide we were talking about says is the basic import thing. Now, some of these libraries, math is a fairly short one, let's be honest, 4 characters. We can all type 4 characters, but some of these things have very long program names, okay? So sklearn is a machine learning package. It's Scientific Kit Machine Learning, or it might be called sklearn for short. Python lets me rename a library when I import it. So I'm making notes up in the actual code, so you have it when I post it to GitHub. We're going to rename the library as part of importing. And that you do that as this, import math as M. Renames math using a shorter name. Now, print m.sine 3.14 over 2. And we see what I've done is I've simply shortened the name. And okay, it's silly for me to do that. It's silly for me to change the name of a 4-letter library, but so be it. But so be it. What I will often do is, give a name to a longer one. Now, as you saw, going back to Chrome, there are a flippin' lot of functions in the math library. Like, I'm bringing in a ton of code when I import math. What if I don't want to import all of the code from math? Well, it turns out I don't have to. What I can do is I can say, these are the functions I want. I just want to import sine. And the way I do that is, as I've already given you in the comment, I will say from math import sine. That just gives me the sine function. Now I don't have the cosine function, but now I can say print sine 3.14/2. This statement has the semantics that Python now knows. When I say sine, I exactly want this. I want the one for math. Why does this matter? This matters because if you go trolling around on the internet looking for Python packages, what you will discover is that there are a lot of different people who've written a sine routine. There are a lot of different people who have written code that claims to calculate the sine of an angle, some of whom do it in degrees, some of whom do it incorrectly and tell you that the sine of pi over 2 is 0. Okay? And so this tells Python the semantics, this is the syntax from math import sine. The semantics of this say only import this function and use this exact one when I say sine, use this exact one from math. I could not immediately follow this and import a sine function from another library. Python would scream, that's inconsistent. Furthermore, for illustration, print cosine of 3.14 over 2. Python is going to tell me cosine is not defined. Well, wait a minute, I imported the math library. Maybe since I didn't say that, I have to say math.cos of 3.14 over 2. I'm not going to do this because since I had previously imported all of math, I would have to go back and do it. But this should still not work if I was doing this demo straight up. Won't work because we only imported sine. Now, the reason that actually worked is because if you go back far enough, I imported all of math, and that's still hanging around. This statement did not overwrite it, so that was kind of cheating. If I go with a new console, I'll do the demo legitimately. From math, import sine, print math.cosine of 0. That should fail. The whole math library is not defined, and cosine is not defined, and everything else. So the point of that particular kind of import, going back to the slides, the point of that is that I am importing only specific functions. You don't have to import all the code. You're not crufting up your system with a lot of unnecessary code. I don't need all the hyperbolic functions. I don't need all the arc functions. I don't need to calculate the median. I don't need exponentiation of the logarithm just to calculate sine. I don't have that code floating around. Okay. Or so as the slide says, if I use this one, the semantics are that this is now a valid reference. If I want to import them all, I use the star. The star or asterisk wildcard means I can import them all, but I don't have to say math dot. I have math dots. Now I can use sine and cosine and tangent and arc tangent. Warning again, if I say from math, import star, import everything, sine, cosine, arc tangent, logarithm, exponentiation, the whole thing, I can use API, function name, and parameters without having to specify math dot. The warning is if you try to do that with two different libraries that have functions with the same name, your results are unpredictable. Python may scream because you have a conflict, or Python may silently pick the last one and figure out that that function definition overrides the previous one. You may not be aware of what you're getting. So if you're importing star, make sure you know what you're importing from. All of these things are ways to import code. The code that you've already written yourself and the code that has been written for you by others. Okay. Now, I give an example. You know, project 2, you had to read in a CSV file and you had to process it in a two-dimensional list. Panel data is a module that, among other things, lets you process a CSV file with a single statement. It does all of that reading and splitting and joining everything for you automatically. Okay. Now, Pandas does not automatically come with every program, with every Python installation, so you might have to install it. This is something you're going to get into with your lab tomorrow. But if you want to install, I'm going to insert a new slide here. Installing packages you don't already have. Okay. There's a couple of different things that you can use. The older and simpler way was called PIP, and PIP is covered in your lab, and it's a small p. And PIP stands for the Package Installer for Python. And PIP goes out and finds the packages that we've talked about, math and pandas and NumPy, and puts them on there. Or you can use Conda. Conda is short for anaconda. Remember Python, the snake metaphor. And these let you install things on your system so that Python knows where you are. Lets you install Python packages so that your Python interpreter knows where they are and can use them. So, getting back to this slide and how I went off on this tangent. If there is a module that you try to use and that you don't already have on your local Python environment, it will squawk and it will tell you, I don't know where that is. And so first you're going to have to install it. Okay. Once you install it, then it's just, all you do is import, and typically people say import pandas as PD. And now the entire file read-in is simply PD pandas dot. The function is read CSV, one of the CSV files from the homework, from the project assignment. And now you have the entire file, and commas can be gotten. This was in a case where I was doing this last semester. I had the extra rows of commas. I warned you there might be some extra rows in the database. Anything that's has no data, that just has commas separating it, you can drop with the drop NA. And so the point is, I'm forcing you in Project 2 to do this the hard way. To read in a file as a string or a list of strings, to separate the strings on new lines and commas, to convert things to integers, to build 2D lists. If you read in, if you installed and used the pandas module, this statement right here does all of that for you automatically. The single statement, because the single statement calls this module, calls this function, read CSV from the pandas module, reads in a CSV file, sets it up. You now have a 2D list with integers, and you're good to go. So it's an example of using code that other people do. And this is always one of the battles. It's not a battle. It's just an interesting discussion we have in teaching this class, is we always get a few people who have actually done programming in Python, or know people who've done programming in Python before, and who say, why are you making me read in this CSV file? I could just import pandas, or there are other modules as well that do CSV files. I could just import and be done in one statement. Why are you making me write functions? Well, you have to learn the computer science, understand how it works, then you can use it. You know, I used to teach calculus many moons ago, and people said, the derivative with respect to x of 3x squared is 6x. Yes, but prove it. Derive it. Show by taking the limit as delta x goes to 0 of 3x plus delta x squared minus 3x squared. Show that that gives you 6x. Work it out, prove it. When you understand the concept, then we let you use the formulas, the cheats to make it simple. Well, in this class, you're getting there. Starting in Project 3, we believe you know the background, you understand how to deal with a CSV file well enough that we will start letting you use these modules to do it. But in Project 2, we forced you to do it the hard way. We forced you to prove that you understand. So think back to your first calculus class when somebody forced you to prove that the limit as delta x goes to 0 to show that the derivative of 3x squared is really 6x. We're at that stage now, but we're getting past it. Okay. This is just an example here that I wanted to bring in of when you bring in the module, you have the code, it's already there. And as you move forward, you've demonstrated a mastery of the topic. You demonstrated that you are truly on top of Python. Now you can start using these tools to make it better. This was the thing I was just talking about, pip and conda, and a little bit I'll give you some demonstrations of that. And this was importing your own code. Okay, this is a summary of what I told you when I lectured that. The rules for importing your own code. The name of the module must end in .py. And it has to be in the Python path. It's simple as to be in the same directory. These are the same things we talked about when you're reading data from a file. You have to be able to find the file. You can, if worst comes to worst, just include the entire darn path name to the file, and you'll get it that way. Now, what I want to talk about, because Project 3 is not out, but this is what it's going to be about. You're going to use Jupyter Notebooks to do data analytics. And I rushed through this last Monday, and I want to talk about it a little more slowly now. Okay. This used to be called the IPython Notebook. It's now the Jupyter Notebook. The people who do this are trying to push Jupyter Lab, but we're going to show Jupyter Notebook with the tools right now. A Jupyter Notebook is just a way of producing an entire report, including text, which they call markdown, kind of somebody's idea of a flippant joke on markup. It's markdown, and executable code and code results. It's an ordered series of cells. You specify the format of each cell. If you have the professional version of PyCharm, which you as students using a UMB account can get free, this is built in, and I'll show you how to work. In the community free version of PyCharm, this is not there. It used to be there. They took it out. They decided to charge for it. Okay, fine. You don't need PyCharm to do this. What I'm going to show you now is how to set up a Jupyter Notebook and get it running in just the generic default case, and then I will show you how to do it in PyCharm Professional. So let me make sure I know how to spell this correctly. Jupyter, by the way, is spelled that way because it's an amalgamation of Julia. The JU is from Julia, PY is for Python, and the TER is just a shortage of the language R. So these were originally set up to work in Julia, Python, and R. Pretty much everybody does them in Python, but it's still called Jupyter, and every now and then somebody tries to pronounce it Jupyter. It's Jupyter like the planet. It's all open source software. The support for it in PyCharm you have to pay for, like I said, unless you have a student account. They have a bunch of tools. Their homepage is jupyter.org. They try to push it to Jupyter Lab. You don't want that. We'll go with the Jupyter Notebook, and we're going to install the Jupyter Notebook. Now, I've already installed it many times on this particular Mac, so we'll see. But if you're doing this not in PyCharm, you install the notebook. Okay. They tell you how to use conda or how to use pip to get Jupyter Notebook running. Okay. I'm doing this on a Mac. It's fairly simple to do it on Windows as well. On a Mac, I'm going to go into my terminal. On a Windows 10 box, I just go into a PowerShell. If you have an older version of, sorry, I was in the wrong place. If you have an older version of Windows, not 10, we may have to talk about how to get this running, but we'll see. Okay. So all I'm going to do on my Mac is I'm going to launch a terminal. And now I'm going to have to figure out how to share a terminal. So give me just a second. Okay, hopefully now you should be able to see the terminal running on my screen. This is just a Mac terminal. And the command is pip install, I think it's notebook. Okay. And all of this junk is coming up on your screen. And when you get your prompt again, that means Jupyter Notebook is now installed on your Mac. Windows is very similar. You just do this in PowerShell. We used pip. The conda command is fairly simple, fairly similar. It's in the thing we looked at. And now to run it, we just type Jupyter Notebook. Okay. This opens a browser window, and here we are. And this is a list that, you know, since it's running as me on my Mac, it has access to my directories. It can tell me what's there. And so a lot of Jupyter notebooks that I've written in my own academic work, plus the students have written in the past, I have a couple of them, plus some other stuff that's all here, but we're going to ignore it for now. We're going to click New. I want a Python 3. You know, it gives me other choices, but everybody does this in Python. So I want a Python 3 notebook. So here it starts a server, and it's now running. And this is a cell. By default, it pops up a new cell. It tells me this is an untitled. So we're going to call this Spring 2021 First Notebook. And it will call it by default. The extension is IPYNB. And again, sure, that's because these were originally called IPython notebooks. So it's IPYNB. And so we have them. And now what I can do is I can just type Python code. What's your first computer program in anything? Hello world. Print hello world on the screen. Hey, we're running Python. Okay. Now I can write anything else I want. This is Python code. I can just put it there. Just for kicks and grins, let's go back to minimize this terminal window. Let's go back to PyChart. Now, this may cause me a problem. Let's go to a different coding file. Okay. Copy the code and put it in a cell of my IPython notebook. Lo and behold, here's my program. Now, the problem is this may fail because I don't know what directory I'm running in right now. So it might not find placeholders. So let me give it the full path. Import /users /Alfred Arsenault / let me go back and find the directory. Where is placeholder.py? Okay. We're going to cheat. I'm going to import the OS library, which is another one in Python that exists. The operating system. Okay, so it should be just user /Alfred Arsenault. Let's go back to, this is all a little experiment because this should theoretically be the correct path. It should now be able to find placeholder. Let's run this cell. Okay. All right, I'll work on this. But the bottom line is if I picked a better program and didn't use an import for something like that, I could copy and paste the whole thing. So this is a Jupyter notebook, and it's a way of writing an entire Python program cell by cell. Now, the other thing it has is I want to change the cell type to what's called code or markdown. A markdown cell lets you control text, headings, things like that. The point is that comments are no longer just ASCII text you put in a program that is very hard to read. You actually document your code in a way that's readable. Then let's put some more code in. Def square number return number times number. Let's insert a cell below and make it a markdown cell. The above is a function definition. Now we can call it from another cell. Let's insert another cell below. Print square of 5. Now, we have to make sure when we run this cell that this cell has already been run. If you run this, gets a little picky. We'll work into it over the next few weeks, a couple of weeks. But you have to make sure when you're running this code that all the cells get run. And as you see, since we did run this first, running a markdown cell does nothing. It just prints the text. Okay, running this cell just prints all that, changes the markdown text into what it actually looks like. This called the function up here and calculated that the square of 25 is going on. So all this is a software development tool where we're building we're using Python, we're using our Python code developer skills, and we're including, embedding is the word I was looking for. Sorry, it's been a long day. We're embedding comments and results with our code to show how we got them. So you should, by Wednesday, when we get moving through this, be able to start. Don't worry about this until you finish project 2, right? Get project 2 done first. But you should be able to get a Jupyter notebook up and running. Okay, we're going to spend a little bit of time on that on Wednesday before we get into sorting and searching. Okay, now I said that in PyCharm Professional, support for this is built in. So what you want to do is in PyCharm, you select a new project. Okay, and it gives you options. Pure Python, Django, Flask, which we may talk about at the end, Web 2, Angular, Lig, Boilerplate, React, React Native. As you'll notice over here, it asks you where you want to put it, directory. Then it talks about what environment you want to use. we're going to have a new virtual environment for the Python interpreter. Okay. I want to make a virtual environment. Now, in PyCharm, unlike GL, it gives you three choices. In your lab tomorrow in GL, you're going to use virtual env and VEv. You can also have pipenv or conda. Where I want to put it, what interpreter I want to use. In this case, I'll use 3.8, but I can use different Python interpreters. I mentioned this early on in the lecture today. With virtual environments, you're not stuck with the same Python interpreter for every project on your laptop. And if you write code that works with 3.8 and 3.9 comes out and it changes something, you can have your old code running with Python 3.8, your new code running with Python 3.9, all of them running in PyCharm, and everything works fine because of this. Your base interpreter, you can inherit global site packages. In other words, any package that's used on my laptop, I want to be able to use from this project, make available, etc. How to do this, okay? These are new things you have with your new project in when you're developing a Jupyter Notebook on Python. Now, I want to check one thing real quick before I move on. I have to check my notes. It's one thing I always miss checking, and then it causes me problems. Specify virtual environment. Okay, so at any rate, you've got your virtual environment. We'll create it. Put this new project in a new window. This takes a little bit of time. Come on. When I dry ran this only took about 2 minutes. It's taking a little bit of time here. Here we go. Notice that PyCharm provides you, if you have professional, an option to create a new Jupyter notebook. So that's it. You specify a new project, tell it a virtual environment, then in your virtual environment, create a new file, and instead of selecting file, which is going to give me a .py, you select a new Jupyter notebook, which is going to give it an automatically give it the IPyNV. So we'll say demo. And in a minute, it'll come back. And here is my Jupyter notebook. This big plus sign right here says put in a code cell or a markdown cell. Insert a code cell. And now over here is what I did in my Chrome browser before. So in this way, you're running Jupyter notebooks in directly in PyCharm, if that's easier. The old way, if you don't want to use PyCharm, if you don't have professional, these are the same cells that you had before. And so it's just a matter of going through and typing and running the same code you did before. And that is where I'm going to stop, since I need you to be able to work on the project 2 stuff. I want to give I've got 5 minutes left in class. I'm going to stop here now. I will get project 3 out as quickly as I can, and we'll talk about it. But I did want to leave open a chance for project 2 questions. I'm going to stop recording. If you don't have any project 2 questions, you can go ahead